Good day, learners! Welcome to Math Corner's General Mathematics for Senior High School, Episode 2, entitled Types of Function. Let us have first a review of what a function is. In mathematics, a function can be defined as a rule that relates every element in one set, called the domain, to exactly one element in another set, called the range. For example, y is equal to x plus 3 and y is equal to x squared minus 1 are all functions because every x value produces a different y value. Let's say, for example, if x is equal to 2, then the value of y is equal to 5. That means in every element of the domain leads exactly to one element of the range. These are the preview of the four types of function. First, general or many-to-one function. Second, injective or one-to-one function. Third, surjective or onto function. Lastly, bijective or one-to-one correspondence function. Let us explore the general or many-to-one function. A general function points from each member of A to a member of B. It never has one A pointing to more than one B, or one to many, but more than one A can point to the same element of B, or many-to-one. That is why it is called many-to-one function, because two or more different inputs can point to the same output. Let's take a look with our example. Consider L, M, N, P, and Q as elements of the input, and 1, 2, 3, 4, and 5 as elements of the output, where L is being associated to 1, M to 2, N to 3, P to 3, and Q to 5. In this case, this is what we call the general or many-to-one function. Two different inputs, N and P, lead to the same output, 3. It is obviously a function because there is no single element in the input that is being repeated. Remember, output can have many input. What is not a general or many-to-one function? Take a look with another example. The same elements in the inputs and in the output, where L is associated to 1, M to 2, Q to 5, N to 3, and 4. In this case, this is not obviously a function because an element in the input is associated to two different output. Remember, input cannot have many output. How about injective or one-to-one function? The injective function f maps values from A to values from B, implies that there is a distinct element of B for each element of A. That means there is a particular element of the output in each element of the input. Every output is the image of a unique input at most one. This implies that an output can be associated only once or not at all with an input. An output should not be taken twice by the input. Consider our example, L, M, N, and P as elements of the input, 1, 2, 3, 4, and 5 as elements of the output, where L is associated to 1, M to 2, N to 3, and P to 4. Observe that each element of the input has a distinct element of an output. The input doesn't share any element in the output. Even if the element of the output 5 is not being associated to any input, it is still an injective function because all other elements has its own pair. Remember, we can have an output B without a matching input A. On the other hand, how does it look like when it's not an injective function? Consider our example with the same elements of the input and the output from the previous example. L is associated to 1, M to 2, N to 3, P to 4, and Q to 4. In this case, this is still a function but not injective function because 4 is paired twice with the input. Remember, every output can be matched at most 1. As I said, this is still a function, particularly a general or many-to-one function. Let's take a look with the surjective or onto function. This is a function for which every element of set B there is a pre-image in set A. This means all the elements of the output should be paired with elements in the input. In other words, no element of the output should be left unpaired. Every element in set B, or the output, has at least one matching in set A, or the input. If in injective, an output can be paired at most 1, in surjective, an output can be paired at least 1. Consider our example, L, M, P, and Q as elements of the input, 1, 2, 3, and 4 as elements of the output, where L is associated to 1, M to 2, N to 3, P to 4, and Q to 4. This is how a surjective function looks like. All the elements in the output are being paired to each element in the input. Remember, every element in set B is an output. As I said, no element of the output should be left unpaired. They can be paired at least once. On the other hand, not surjective or onto function looks like this. Consider the same elements from the previous example, where L is associated to 1, M to 2, N to 3, P to 4, and Q to 4. At first, it looks like a surjective function, but it is not, because an element 5 in the output doesn't have any pair in the input. But the truth is, this is still a function. Remember, there won't be an element in set B left out. In this case, this is an example of general or many-to-one function. Let's have the last type of function, which is bijective or one-to-one correspondence function. Bijective means both injective and surjective together. Think of it as a perfect pairing between the sets. Everyone has a partner and no one is left out. In other words, this is a perfect function. Every element has its own pair and no one is left unpaired. Let's take a look with our example. Consider L, M, N, P, and Q as elements of the input, and 1, 2, 3, 4, and 5 as elements of the output, where L is associated to 1, M to 2, N to 4, P to 5, and Q to 3. If we will take this concept in a relationship, everyone looks happy because they all have their own pair and no one is left unpaired. Remember, every element has a pair and no one is left out. How does not bijective function looks like? Consider the same elements from the previous example, where L is associated to 1, M to 2, N to 3, P to 4, and Q to 4. Obviously, this is not bijective, since 5 is being left out and 4 has two different elements of the input. In this case, this is an example of general or many-to-one function. Now, it's your turn. Identify whether the following diagrams shows general, injective, surjective, or bijective function. Let's have diagram number 1. What type of function is this? Brilliant! This is a bijective or one-to-one correspondence function. Consider diagram number 2. What type of function is this? Clever! It is a general or many-to-one function. How about our last diagram? What type of function is this? That's great! It is a surjective or onto function. Thank you for watching. I hope you learned something from the video for today. See you on my next episode. Goodbye!